How can LoRA drastically cut LLM training time? Imagine being able to teach a giant language model in a fraction of the time it normally takes. Sounds like magic, right? Well, it's actually a smart trick called low-rank adaptation, or LoRA for short. This method is changing how we fine-tune large language models and making it faster and cheaper. Let's see how it works. Large language models are like huge libraries with billions of words and connections. To customize them for specific tasks, you usually need to update a lot of these connections. But that takes a lot of time and computer power. LoRA changes that by only updating a small part of the model. It does this by breaking down the weight updates into tiny, low-rank matrices. Think of it like fixing only a few pages in a big book instead of rewriting the entire thing. The main idea is that LoRA keeps the original model weights frozen. That means the model stays the same, and you only train these small low-rank matrices. Since fewer parameters are changing, the training process becomes much faster. It also uses less memory on your graphics processing unit, which is the hardware that does all the heavy lifting. This means you can fine-tune models on less powerful hardware and still get good results. Another clever part is that once you train these low-rank matrices, you merge them back with the original model. This way, when you run the model later, it works just as fast as before, without extra delay. So, training time drops but performance stays high. Plus, because large models tend to have more parameters than they actually need, LoRA takes advantage of this over-parameterization. It updates only the essential parts, saving time and resources. Some extensions like Quantized Low-Rank Adaptation combine LoRA with quantization, which reduces the numerical precision of the data, and pruning, which removes less important parts of the model. These tricks push efficiency even further, allowing training of very large models on limited hardware in a shorter period. From a broader view, LoRA is part of a trend to make AI more accessible. Instead of needing huge data centers and weeks of training, developers can now fine-tune models quickly and affordably. This means faster development cycles, lower costs, and easier experimentation. You can adapt a pre-trained model to a specific task in hours instead of days or weeks. In simple terms, LoRA is like giving a giant model a quick, targeted tune-up instead of a full overhaul. It cuts down training time dramatically, saves resources, and opens up new possibilities for everyone working with artificial intelligence. That's how this clever technique is helping shape the future of emerging AI technologies.